Good morning, friends. Now I am going to discuss about a problem that is related with the eigenvalues and eigenvectors. Okay. Now I am taking one 3 by 3 problem. In that the roots are repeated. If the roots are repeated, how we can find out the eigenvectors corresponding the eigenvalues? Okay. If the roots are distinct, then we can find out the for different roots we can find out corresponding eigenvectors. If the roots are repeated, means for that repeated root we can find out only one eigenvector, that is the same as for another root also. That is the difference. Okay. Now I am taking one problem to find the eigenvalues and the eigenvector and the corresponding eigenvector of a matrix, that is 1 1 1 1 1 1 1 1 1. Okay. The same procedure, how we can find out the eigenvalues and eigenvectors. The eigenvalues can be found out by using the characteristic equation. What is the characteristic equation? The characteristic equation is determinant of a minus lambda I is equal to 0. That is nothing but only the diagonal elements are subtracted lambda with lambda. Okay, the lambda is subtracted from the diagonal elements. Now we can take a matrix, that is 1 1 1 1 1 1 minus lambda into identity matrix is 1 0 0 0 1 0 0 0 1. This determinant is equal to 0. Okay, then the determinant of a matrix is 1 minus lambda 1 1 1 1 minus lambda 1 1 1 1 minus lambda is equal to 0. To find out the determinant, okay, that is 1 minus lambda into elimination of corresponding row and column. The remaining is, this is the 2 by 2 matrix, that is 1 minus lambda into 1 minus lambda minus of 1 into 1. The second element is negative minus 1. Surely that is negative. Why? Because that is in the first row, second column, minus 1 whole power 1 plus 2, that is the 3. If negative of odd power is negative only, that is the multiple is 1, the corresponding row and column. 1 into 1 minus lambda minus 1 into 1 plus again 1. This is the first row, third column means 1 plus 3 minus 1 whole power 1 plus 3, this is the 4, it is becomes 1, that is positive. Corresponding column and row elimination, 1 minus 1 into 1 1 minus of 1 minus lambda, 1 into 1 1 minus of 1 into 1 minus lambda is equal to 0. That is 1 minus lambda into multiplication of these factors, 1 into 1 1 minus lambda minus lambda minus into minus plus lambda square minus 1 minus 1 into 1 minus lambda minus 1 plus 1 into 1 minus 1 minus into minus plus lambda is equal to 0. Plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 get cancelled. Here 1 minus lambda into minus lambda, this is minus 2 lambda plus lambda square, minus into minus plus lambda, plus into plus lambda is equal to 0. Okay, again multiply. 1 into minus 2 lambda plus lambda square, minus into minus plus 2 into lambda into 2 lambda square, minus lambda cube plus lambda, that is plus 2 lambda is equal to 0. Here minus 2 lambda plus 2 lambda get cancelled. From this minus lambda cube plus 3 lambda square is equal to 0. Here minus lambda square taking common, the remaining is lambda minus 3 is equal to 0. Therefore lambda equal to lambda square is 0, lambda minus 3 equal to 0. For this lambda square is 0 means lambda is 0 comma 0, and this minus 3 is taking to right side, then that is a plus 3. Therefore the eigenvalues are 0 comma 0 comma 3. These are the eigenvalues. Now to find out the eigenvectors. From the case 1, in the case 1, take lambda is equal to 0. Here lambda is 0, 0. In these two are repeated roots. For that we can find out corresponding eigenvector for lambda equal to 0. How we can get the parameters. Here two roots are repeated means the reducing of echelon form in the A minus lambda I matrix, the two rows will be 0. Just you observe that one. How we can get the repeated roots? What is the change of distinct roots and repeated roots? If the repeated roots means two rows will be 0 by the reduction of echelon form. If one root, that is nothing but the roots are distinct means we are getting by reduction of echelon form only one row will be 0. Okay, just we take lambda equal to 0 is the eigenvalue. Let capital X is equal to x1, x2, x3 be a corresponding eigenvector. Be a corresponding eigenvector. Okay. Take the characteristic vector equation. For the vector equation. For the eigenvalues, characteristic equation only. The characteristic equation, vector equation is A minus lambda I into x is equal to 0. Here x is this eigenvector x1, x2, x3. Lambda value is we can take lambda equal to 0. That 0 is we can substitute in the A matrix. Then that is 1 minus 1. So 1 minus 0, 1, 1, 1, 1 minus 0, 1, 1, 1, 1 minus 0 into x1, x2, x3. And this 0 matrix becomes a column matrix. Why? Because it is 3 by 3 into 3 rows, 1 column. We are getting the 3 rows, 1 column. 3 by 3. 3 by 1 only. Okay. This matrix is no change of A, 1, 1, 1, 1, 1, 1, 1, 1, 1. It is x1, it is x2, it is x3. This is equal to 0, 0, 0. Okay. here observe this A matrix. In this, all rows are same, just we are reduced. These two elements are 0 by using of row elementary operation. R1 is as it is R1, R2 is R2 minus R1, R3 is R3 minus R1. Then the A matrix becomes 1, 1, 1, 0, 0, 0, 0, 0, 0 into x1, x2, x3, that is equal to 0, 0, 0. And it can be write in the equation form by multiplying of these two matrices. Then the matrix equation x1 plus x2 plus x3 is equal to 0. In this, 3 variables and only one equation. Okay. By the rank of matrix form, how we can find out the consistent? That's in this, any two parameters we can take any two variables as a parameters, either x1 x2 or x2 x3 or x1 x3, our wish only. I am taking here like x1 is equal to k1 and x2 equal to k2 or parameters. These x1 and x2 values substitute in above equation. Then x3 becomes x3 equal to minus x1 minus x2. x1 is minus k1, x2 is minus x2 is k2. Therefore, x3 is minus k1 minus x2. Therefore, the eigenvector is x1, x2, x3 variables. Those variable values are k1, k2, minus k1, minus k2. In this matrix, we can take k1 parameter outside, then it is 1. In the second row, no k1, 0. In the third row, minus 1. Plus k2. In the first row element is 0, no k2. Here 1, here minus 1. Therefore, here 1, 0, minus 1, 0, 1, minus 1 are the characteristic or eigenvector of A when lambda equal to 0. This is the case 1. Okay. When lambda equal to 0. Next, case 2. The another value is, in the case 2, take lambda equal to 3. In the previous problems, the eigenvalues are distinct, means we are getting the only one row will be 0. Then in the characteristic vector, only one vector is appear. Okay, here the root is repeated, means in this matrix 2 rows will be 0. From the 2 rows means we are getting the only one equation with the 3 variables. In that we can take any 2 variables or the parameters and substitute and find out the third variable. And those we can write in the column form and taking common parameters. So we are getting the 2 eigenvectors for the given matrix A of when lambda is equal to the corresponding root. Okay. Here case 2, lambda equal to 3. In this, let x is equal to x1, x2, x3 be a corresponding eigen vector. Okay. What is the eigenvector equation? The eigenvector equation is determinant, equation is just simply a minus lambda I into x is equal to 0. Here a is 1 minus 3, 1, 1, 1, 1 minus 3, 1, 1, 1, 1 minus 3 into x1, x2, x3 is equal to 0, 0, 0. Simplification of this matrix. 1 minus 3 is minus 2, 1, 1, 1 minus 2, 1, 1, 1 minus 2 into x1, x2, x3 is equal to 0, 0, 0. By using row elementary operation, we can reduce into echelon form these two. First, these two elements reduced into 0. Okay. In this, R1 is R1 only. R2 is 2R2 plus R1. R3 is 2R3 plus R1. Okay. The matrix is first row as it is minus 2, 1, 1. It is multiplied with 2 and add these two rows. 2 minus 2 it is 0. Minus 4 plus 1 it is minus 3. This is minus 3. 2 plus 1 that is 3. It is 3. The same way the third row is multiplied with 2. 2 minus 2 it is 0. 2 plus 1 it is 3. Minus 4 plus 1 it is minus 3. This is minus 3. So x1, x2, x3 is equal to 0, 0, 0. Okay. Next, this element is reduced to 0. Third row, second element. Okay. From this, R3 is R3 plus R2 and R2 is divided with 3 only. Then A matrix becomes minus 2, 1, 1, 0, minus 1, 1, 0, 0, 0 into x1, x2, x3 is equal to 0, 0, 0. Here only one root is there, so one row will be 0 by reduce of echelon form. Okay. Here that matrix is multiplied, two matrices are multiplied and that can be expressed into equation form. That is minus 2x1 plus x2 plus x3 is equal to 0. Minus x2 plus x3 is equal to 0. In this, take any one of the variable is parameter. Here x3 is equal to some k is a parameter. Then x2 equal to x3, that is k. And x2 and x3 values substitute in above equation, that is 2x1 is equal to x2 plus x3, that is equal to x2 is k, x3 is k, k plus k, that is 2k. Then x1 is equal to 2k by 2, 2 get cancelled. That is also k. Therefore, capital X is equal to k, x1, x2, x3. Those values substitute in this matrix. x1 is k, x2 is k, x3 is k. So, taking common k from that matrix, 1, 1, 1 be a eigenvector corresponding eigenvector of lambda equal to 3 when lambda equal to 3. This is the procedure. Okay. The main thing is the roots are distinct means we are getting the only one row will be 0 in the characteristic vector equation or eigenvector equation in the reduction of echelon form. If repeated means how many repeated, then such rows will be 0 in that reduction of echelon form. Okay. Thank you.